Doesn't sound good. Bigger stuff. Get back over there. All right, unusually low, X or fewer, so 900 out of 1,000, back to 900 or more. Where's that 5% probability? Where's that 5% probability for fewer than that? Usually high, usually low. Those are the probability's got to be less than 5% for that. 5% or less. 5% or less. That's unusual. If you're thinking about betting and things like that, the probability, if it's 5% or less, the payout is usually more. Because it's not likely anybody's going to win with that choice. So does the Powerball is much less than 5% chance of one person winning the whole jackpot. It's a very, very small probability. So that's why it climbs so high.
It's like horse betting.
Sorry. Almost doing this.
But I would really say that.
No, you wouldn't. No, because then I'd have to go buy a new one.
How long would that take?
To buy a new one of these? Well, consider my mother-in-law works at ACO, which sells these things. Tomorrow, I'd have one.
After school.
Yeah, probably.
It goes off again, place throw.
No, I'm
gonna try to keep home. Oh, the wall will get my picture.
Okay. All right. Unusually low, 5% or less. All right. So what I want to do is look at a couple of examples in your book. So I need you to open up page. Let's do the page 198 and 199. Examples. Example 1, we've already talked about the births. Looking at examples 2 and 3 there. Okay. Example 2, Pew Research poll. They get some information. There's a table on the right side. So you're going to have to refer to some tables as you're doing work here. Consider the 3 requirements. They want to know, does that describe a probability distribution? What are the 3 requirements for a probability distribution? What are those 3 requirements? That's good. Numerical random value. What's our response on that table over there? Yes, no, and don't know. Is that numerical? No. So part 1 is not met. If it doesn't meet all 3 parts, it can't be a probability distribution. Even though we've got the table has probabilities listed there, but it doesn't meet the requirements to be a probability distribution. So we can't classify that as one. It does have the sum of those probabilities. If you add 0.41, 0.52, and 0.7 together, you do get 1. It meets condition number 2, and it also meets condition number 3, but it doesn't meet condition number 1. So if it fails any of those 3, it's not a probability distribution. Okay, so be careful of that because it looks a lot like 1, but the fact that your response is or your X is not a numerical value. Example 3, there's an example of one that is. You've got a table over there on the right, 5, 3. Your X, your number of interviews, is your random variable. 1, 2, or 3. You got probabilities over there. You add up those probabilities, though. You've got a numerical value, so condition 1 is met. But when I add up my values, 0.3, 0.26, and 0.1, that doesn't add up to be 1, does it? So it fails part 2 of that. Okay, so we lose part 2. So if it fails one of the pieces, it's not a probability distribution. So we could have a numerical response or variable, but we don't have the right probability sum there. So that one fails that. Example 4 there, we've got a different situation. This probability of x equaling x divided by 3, where x can be 0, 1, or 2, determine a probability distribution. Okay. If the probability is found by taking the random variable x and dividing it by those options, 0, 1, and 2, does that turn, can we build a probability distribution off of that? Is the x numerical? Yeah, they told me it could be 0, 1, or 2. Those are all new numbers. That's numerical. And then is does 0 out of 3 plus 1 out of 3 plus 2 out of 3 add up to be 1? 0 plus 1 plus 2 is 3 over 3, 1. It does. Are all of those probabilities between 0 and 1, including 0 and 1? 0 out of 1, 0 out of 3, that's 0. It works. 1 out of 3, 1/3, 0.33, right? That's between 0 and 1. Works. 2 out of 3, 0.66. That works. And then we can't. They told us 3 out of 3 wasn't an option. So all of those are between that. Because it meets all 3 requirements, it could be a probability distribution out of that. Okay. Mean, variance, standard deviation. There's an example that we actually did on the screen there. Example 5. You can slip down there to example 6, and you see the range rule of thumb that we did on the screen, and then example 7, unusual events. There, if you look at that on page 204, example 7. 945 births, or what is the size of everything? 879 girls out of 945 births. Oh, wow, that's a lot. Okay. So here's the situation here. What does this suggest about the effectiveness of the X-sort method for gender selection? X-sort method is the centrifuge when they spin. Well, the X-sort method spins the sperm to where you got male and female out of that, the X and Y. So the X-sort, we're trying to get